All right, so get this. We are living inside of a giant swirling galaxy. Not just any galaxy, the Milky Way galaxy.
Yes.
And today, we are going deep, deep,
Oh,
deep
I like it.
into its structure,
Okay.
its mysteries and future exploration. And we've got a fantastic source today.
Okay.
An episode transcript packed with insights. So get ready for some aha moments. We're
Yeah.
about to become Milky Way experts.
I love it.
What's fascinating
What's
is
fascinating is we're not just passively observing this galaxy, right? We're actively piecing together its story using cutting-edge technology and some of the brightest minds in the world.
I love that we're like galactic detectives, right?
Exact.
So before we get to the mysteries, let's set the scene.
Okay.
What are we dealing with here? Scale-wise, how big are we talking?
Okay, so imagine this. The Milky Way is over 100,000 light years across.
Wow.
That means light from one end takes 100,000 years to reach the other.
It's mind-bogglingly vast.
It is.
It is.
It's huge.
Okay, so it's big.
Yeah.
But what's it made of?
Okay.
Is it just stars or is there more to it?
It's not GST stars, although there are an estimated 400 billion of them.
400 billion stars.
Yeah, each a potential sun,
Wow.
maybe with its own planetary system, but
Right.
the Milky Way is also made up of gas, clouds, dust, and something we can't see directly. Dark matter.
Okay, hold on. Dark matter.
Yes.
That sounds like something straight out of science fiction. What is that exactly?
It is one of the biggest mysteries in astrophysics.
Really?
We can't see dark matter, but we know it's there because of its gravitational effects.
Oh, okay.
Without it, galaxies would simply fly apart.
So it's like the glue holding everything together.
It is like the glue.
Wow.
Yeah.
Okay, so we've got stars, gas, dust, and this invisible dark matter holding it all together. But is it just randomly scattered, or is there some kind of structure to this galaxy?
The Milky Way has a definite structure. It's a spiral galaxy,
Okay.
which means it has a central bulge surrounded by a flat disk with spiral arms winding outwards.
Spiral arms, like actual arm
Yeah.
spiraling up.
Yeah.
How did those even form?
That's a great question, and it ties into how galaxies evolve over time.
Okay.
So the Milky Way likely formed from the merging of smaller galaxies over billions of years.
So the Milky Way wasn't always this grand spiral.
Right.
It was built up over time,
Exactly.
like a giant cosmic construction project.
Precisely. And that building process isn't over. In fact, the Milky Way is on a collision course with our neighboring galaxy Andromeda,
Oh, wow.
billions of years from now.
Wow, that's incredible.
They will merge.
Okay, so we'll table that for later.
Yes.
But for now,
Yes.
let's zoom back into our little corner of the Milky Way, this Orion arm we call home. What's it like here compared to other parts of the galaxy?
Well, it's relatively calm and stable here, which is probably why life was able to evolve on Earth.
I see.
We're far from the intense radiation and gravitational forces, closer to the galactic center.
It's like we're in the suburbs enjoying a peaceful existence away from the hustle and bustle of downtown. I like that analogy.
Good.
So we're in this nice, quiet neighborhood with billions of stars as our neighbors.
Yes.
But I have to ask, if the Milky Way is so vast, are we the only ones here?
Right.
Could there be other forms of life out there?
Now that's the million-dollar question, isn't it?
It is.
And that brings us to one of the most exciting areas of research, which is exoplanets.
Exoplanets.
Yes, these are planets that orbit stars other than our sun.
Okay.
And the Milky Way is teeming with them.
Wait, really? There are planets out there orbiting other stars. How many are we talking about?
Thousands have already been discovered, and many more are waiting to be found.
Wow.
What's even more exciting is that many of these exoplanets lie within what's called the habitable zone
The habitable zone
of their star.
of their stars.
The sweet spot where temperatures could allow for liquid water to exist.
One,
Yes.
habitable zone, you're saying there could be planets out there with oceans,
Yes.
maybe even continents.
Exactly.
It's a mind-blowing possibility.
It really is.
We're just beginning to scratch the surface of what's out there.
We are.
Okay, now I'm really curious. How do we even know all of this?
Yeah.
How are we able to study things that are so incredibly far away?
We have some incredibly powerful tools at our disposal, for example. The Gaia spacecraft is creating the most detailed 3D map of the Milky Way ever made.
Oh,
It's like having a GPS for the entire galaxy,
wow. Okay.
charting the positions and movements of over 1 billion stars.
1 billion stars.
1 billion stars.
Well, it's hard to even wrap my head around that.
Yeah.
So this Gaia spacecraft is giving us a much clearer picture of what the Milky Way actually looks like.
Absolutely. And then there's the James Webb Space Telescope, which is peering deep into the cosmos and capturing stunning images of star-forming regions and the early stages of stars and planets being born.
So we can actually watch stars and planets being born.
It is like having a time machine, allowing us to witness the birth of stars and planets.
So we're using this incredible technology to map the galaxy, peer back in time, and even search for other planets that could potentially harbor life.
Exactly.
This is getting really exciting.
I know.
All right, so we've covered the basics, the Milky Way's structure, its formation, and some of the incredible tools we're using to study it.
Yeah.
But what about those mysteries you mentioned?
Yes.
What are some of the big unanswered questions that keep astronomers up at night?
Well, we've touched upon one already, which is dark matter.
Right.
We know it's there, but we still don't know what it is.
Right.
And that's just the tip of the iceberg.
Yeah.
There are so many more questions about the Milky Way that are still waiting to be answered.
Okay, you've definitely piqued my curiosity.
Good.
Let's dive into those mysteries next.
So we were just talking about dark matter.
Yeah.
And it really is one of the most baffling mysteries in astrophysics.
Right.
We know it makes up the vast majority of the Milky Way's mass, but its nature remains elusive.
So we're talking about something that holds the entire galaxy together, but we have no idea what it is.
Pretty much.
That's kind of unsettling, isn't it?
It's definitely one of the biggest challenges in cosmology.
Wow.
There are many theories about what dark matter could be.
Okay.
From exotic particles we haven't detected yet to entirely new forms of matter that interact with the universe in ways we don't fully understand.
So it's not just a case of finding dark matter.
Right.
It could require a completely new understanding of physics.
Exactly. It's pushing the boundaries of our knowledge and forcing us to rethink fundamental assumptions about the universe. And it's not just dark matter that poses a puzzle.
Right.
Another big mystery is how the Milky Way got its spiral shape in the first place.
I was wondering about that.
Yeah.
You mentioned earlier that galaxies form through mergers. But how does that chaotic process lead to these beautiful symmetrical spirals we see in images of the Milky Way?
It's a complex process.
Okay.
But the leading theory is that those spiral arms are actually density waves, kind of like ripples in a pond. As these waves move through the galaxy's disk, they compress gas and dust, triggering bursts of star formation.
So the spiral arms aren't fixed structures.
No.
They're more like waves of activity moving through the galaxy.
Precisely. And that means that the Milky Way is constantly evolving, with stars being born and dying and the spiral arms shifting and changing over time.
So it's a dynamic living entity.
It is.
It's amazing to think that our galaxy is in constant motion, even though it seems so static from our perspective here on Earth.
Yeah, it is. And those changes aren't limited to the Milky Way itself. As we mentioned before, our galaxy is on a collision course with the Andromeda galaxy.
Yes, the big galactic merger.
Yes.
What will happen to our little solar system when that happens?
Well, it's billions of years in the future.
Oh,
So we have some time to prepare.
I was going to say.
But when those two galaxies collide, it will be a spectacular event. Stars will be flung around, gas clouds will collide, and new stars will be born.
Wow.
It's difficult to predict exactly what will happen to our solar system, but it's likely that we'll be flung into a new orbit, perhaps even farther out from the galactic center.
So we could end up with a whole new view of the night sky.
Exactly.
That's pretty cool.
It is, and it underscores the fact that the Milky Way isn't just a static backdrop. It's a dynamic system that's constantly changing and evolving.
Okay, so we've got dark matter, spiral arms, galactic mergers. It seems like there's a lot we still don't know about the Milky Way.
Right.
But what about life beyond Earth? Are we getting any closer to answering that question?
That's another area where there have been incredible advancements in recent years.
Okay.
The discovery of exoplanets, planets orbiting other stars, has revolutionized our understanding of planetary systems.
We touched on exoplanets earlier, but I'm really curious to learn more.
Okay.
What are we finding out about these distant worlds?
We're finding that planetary systems are incredibly diverse.
Oh.
There are gas giants, larger than Jupiter, rocky planets like Earth and everything in between. And many of these planets orbit their stars within the habitable zone, where conditions could be right for liquid water and potentially life.
You keep mentioning this habitable zone.
Yeah.
Can you explain exactly what that means?
It's essentially the region around a star where temperatures are just right for liquid water to exist on a planet's surface.
Okay.
Not too hot to boil it away, not too cold for it to freeze solid.
So it's the Goldilocks zone for planets.
Exactly.
Not too hot, not too cold, just right. But even if a planet is in the habitable zone,
Yes.
doesn't that mean it automatically has life?
Not Not necessarily.
Okay.
There are many other factors that come into play,
Like what?
such as the planet's atmosphere, its magnetic field, and its geological activity.
So just being in a habitable zone is a good starting point.
Yes.
But it's not a guarantee of life.
Right.
Makes sense. So we're still searching for those telltale signs of life
Yeah.
on other planets. What are some of the things scientists are looking for?
One of the key things is the presence of certain gases in a planet's atmosphere. For example, oxygen, methane, and water vapor can all be indicators of biological activity.
So we're essentially sniffing out alien atmospheres.
Pretty much.
That's pretty amazing.
It is, and there are other clues we can look for as well,
Oh, like what?
such as variations in a planet's light as it orbits its star, which can tell us about its surface features and potential oceans.
Wow.
Yeah.
Okay, so there's still a lot we don't know, but it sounds like we're making progress in our search for life beyond Earth, and it all comes back to the Milky Way, this incredible galaxy we call home.
It does, and the more we learn about the Milky Way, the more we realize how much more there is to discover.
Speaking of discoveries, we were talking earlier about some of the amazing technology that's helping us explore the galaxy.
Yes.
Can you tell us more about how these tools are shaping our understanding of the Milky Way?
Absolutely. The Gaia spacecraft, which we mentioned before, is truly revolutionizing our view of the Milky Way. It's not just mapping the positions of stars, it's also measuring their movements and compositions, which is giving us unprecedented insights into the galaxy's history and evolution.
So it sounds like Gaia is giving us a much more dynamic picture of the Milky Way, not just a static snapshot.
Exactly. And then there's the James Webb Space Telescope,
Right.
which is pushing the boundaries of what we can see in the universe. Its infrared vision allows it to peer through dust clouds and observe the earliest stages of star and planet formation.
So we can actually watch stars and planets being born?
We can.
That's mind-blowing.
It is, and it's helping us to answer some of the fundamental questions about how planetary systems form and evolve.
I have to ask, what about the future?
Yeah.
What other mysteries are we hoping to solve?
Well, there's still so much to learn about dark matter. We need to develop new technologies and techniques to directly detect and study this elusive substance, and we're just beginning to explore the vast diversity of exoplanets. Future missions will aim to characterize these distant worlds in more detail, searching for signs of atmospheres, oceans, and perhaps even biosignatures, those telltale signs of life.
Okay, we've covered a lot of ground here, from the mysteries of dark matter and the dynamics of spiral galaxies to the search for life on other planets.
Yeah.
What's the big takeaway for our listeners?
I think the key takeaway is that the Milky Way is a dynamic, evolving entity full of wonders and mysteries.
Mm-hmm.
And as we continue to explore and learn, we're not just unraveling the secrets of our galaxy, we're also gaining a deeper understanding of our place in the cosmos.
Beautifully said. So what's next for our deep dive into the Milky Way?
Well, we've talked about the present and the past. Now let's take a look at the future of Milky Way exploration.
So we've explored the structure and the mysteries of the Milky Way.
Uh-huh.
Now let's turn our gaze to the future. What's on the horizon for Milky Way exploration?
The future is incredibly exciting. There are some really ambitious plans for missions that will push the boundaries of our knowledge even further.
Give me some specifics. What kind of missions are we talking about?
Well, for one, there's a growing interest in studying the dark matter halo in more detail. Remember, that's the vast, invisible sphere surrounding the Milky Way
Right.
that's thought to be mostly dark matter.
Right, the cosmic glue. But if we can't even see dark matter, how do we plan to study it?
Well, that's the challenge. Scientists are developing new techniques and instruments that might be able to indirectly detect dark matter particles
Okay.
or map their distribution within the halo. Some of these involve looking for subtle gravitational effects
Okay.
or searching for evidence of dark matter interactions with ordinary matter.
So we're talking about some serious detective work here.
We are.
What else is on the agenda?
Well, exoplanet research is another really hot topic. We've identified thousands of exoplanets, but we've only just begun to scratch the surface. Future missions will aim to characterize these planets in more detail, looking for signs of atmospheres, oceans, and even potential biosignatures.
Biosignatures.
Yes, those telltale signs of life.
So we're not just looking for planets anymore, we're looking for signs of life on those planets.
Exactly, and the technology is getting more and more sophisticated. There are proposals for space telescopes that would be able to directly image exoplanets and analyze their atmospheres, looking for those chemical fingerprints of life.
That would be incredible. Imagine actually seeing an alien world and knowing that it might harbor life.
It's a tantalizing prospect, and there are other exciting avenues of research as well. For example, there are plans to use gravitational waves to study the Milky Way's dynamic nature.
Wait, gravitational waves, those ripples in space-time caused by massive objects.
Yes.
What can they tell us about the Milky Way?
Well, gravitational waves can reveal events that we wouldn't be able to observe with traditional telescopes, like the merging of black holes or the collision of neutron stars.
Wow.
By detecting these waves, we can learn about the distribution of these objects within the Milky Way and gain insights into the galaxy's overall evolution.
So it's like listening to the heartbeat of the Milky Way,
Huh?
using gravitational waves to understand its inner workings.
That's a great analogy, and it highlights how our understanding of the Milky Way is becoming increasingly multifaceted. We're using every tool at our disposal, from traditional telescopes to cutting-edge gravitational wave detectors, to piece together the story of our galaxy.
It's truly an exciting time to be studying the Milky Way. But all this talk about future missions and technology makes me wonder, will humans ever venture beyond our solar system to explore these distant worlds firsthand?
That's the ultimate dream, isn't it?
It is.
While interstellar travel still presents immense technological challenges,
Yeah.
it's not entirely out of the realm of possibility.
Okay.
There are ongoing research efforts focused on developing new propulsion systems, such as fusion drives or solar sails, that could potentially enable us to reach the stars. So you're saying there's hope? Maybe one day, humans could walk on the surface of an exoplanet, breathe its air, and see its alien landscapes with their own eyes.
It's a possibility that captures the imagination, and even if it takes centuries to achieve the pursuit of that dream, drives innovation and pushes the boundaries of what we believe is possible.
That's what I love about space exploration. It inspires us to think bigger, to push the limits of our knowledge, and to never stop asking questions. So as we wrap up this deep dive into the Milky Way, what's the final message you want our listeners to take away?
The Milky Way is our galactic home, a place of wonder, mystery, and endless possibilities. Every star we see in the night sky is a part of this incredible system, and we're just beginning to understand its complexities. As we continue to explore and learn, we'll undoubtedly make new discoveries that will challenge our assumptions and expand our understanding of the universe.
Beautifully said, and for you, dear listeners, you gaze up at the Milky Way tonight. Remember this, we're all part of something much bigger than ourselves, a vast and ancient cosmic tapestry that's still being woven. Keep looking up, stay curious, and never lose your sense of wonder. Who knows what amazing discoveries await us out there in the vastness of space?